Hi friends, welcome to Machine Learning Journey. This is lecture 6 of our ML series. In this lecture, we will mainly understand about training and testing data. What is the requirement of this data in the machine learning or model development work? So far we have discussed about AI versus ML differences versus between DL or GenAI. Overall, AI is the uppermost layer, or I would say GenAI is a subset of deep learning. Deep learning is a subset of machine learning, and machine learning is a subset of AI. In the next lecture, we understand about what is data and its type. Then we understood about features and labels. Features are input signals, and labels are the output or the ground truth, which is denoted by Y. Features are denoted by X. And now we will discuss about we have also discussed about types of machine learning, types of ML, and then later on we checked about supervised learning types, that is classification and regression. Classification are based on the category, regression is based on the number, the output. Output is category, then it is a classification task. Output is a numbers, then or continuous prediction, then it is a regression task. In this lecture, we will understand about training data and testing data. So now let's say there is a one student and you are the teacher and you want to teach something to your student. So for example, we'll take one example. Let's say any one subject you are teaching and you have one book and you will teach this book to student, and then you will ask questions in the exam, and on the basis of the marks he he achieve, you will check his performance or the understanding about the subject. So now this is the overall flow you will follow. Now what if like the questions you will set, like let's say you will ask 10 question out of this book. Once you finish your teaching, you will ask 10 questions. What if you like reveal this 10 questions and student just memorize it, and then he got full marks, 100 out of 100, let's say. And then how you will evaluate that marks, like, because since the student has already seen the 10 questions, will he focus on the learning or understanding of the book or not? So that's how, like, in the machine learning also, the thing is, when you have one data, let's say when I say you have data, and then uh, I, when I say a data, it means it has some X and Y. Some X input features can be N features, and then there is a Y, which is the output or ground truth you have. Now, in the machine learning itself, what is learning? Basically, the learning is you have a X input features, Y output or ground truth. Now, you want to teach your model to catch the pattern. Teach your model to catch pattern. Okay, you will get some pattern, and out of this pattern it will answer the next new unseen data. Okay, the new X dash is a unseen data, let's say, and it will after checking the prediction of unseen data, you will evaluate the performance, that how is performing. Now, for example, let's say you want to teach the student about the prediction of a next number given four numbers. So let's say you teach students, like, if the series is like 2, 4, 6, 8, and you want to predict next number, it is 10. Let's say 3, 6, 9, 12, and next is 15. Likewise, you teach the sequence. to students. Now, in the exam, you will ask one question, and on the basis of that one question, or you may ask some 10 questions, let's say, and on the basis of test 10 questions. So, what you will do, how you will check the understanding of students after teaching this sequence of numbers prediction. So here, if you ask directly this question 2, 4, 6, 8, and if student says 10, will it be a fair evaluation technique? Because since like think again, this question was already there in the your teaching patterns, like your teaching set. So if it is already there is a high chance that student just memorize it, that 2 4 6 8, then blindly answer 10. There is no understanding of pattern. Since you have taught them to understand the patterns and then predict the next number on the basis of that pattern you have taught, not the just four numbers, right? So now let's say these are the 3 4 5, like this you have taught the series, and then you answer, you give the question like that, a little tricky, let's say 11, 22, 33. Now student will say this sequence I have not seen, but previously my teacher taught me that if this kind of sequences are there, you just need to subtract the next number from previous number and check the differences. If differences is a constant, that is AP, and the next number will be the last number plus the difference, that is 11. So he will learn that pattern and then he can answer the question. The same thing in the machine learning itself. When you have data, instead of giving complete data a model to a model, you just give some part of data, let's say. So most of the things you want to keep for teaching, because that's how the student will learn. So same is in the model also, you keep like 70 to 80%, it depends on the standards, like your requirement, but 70 to 80% data you keep for learning, and then rest of the data which is unseen to the model, you uh, keep for testing the model for performance. So for this data, 70 to 80% and 20%, you divide that. This both data has no intersection. So now this 70 to 80% data is used for teaching or recognition of patterns or learning. Then this 20% unseen data is used for performance evaluation. Now I hope you understood that why this data needs to be divided, or why we need a separate test set to basically know the performance. Because if you make a model, ML model, so without checking the performance, you can't deploy it in the production. Otherwise it can affect the complete business, right? So if you create a model and then you say how much confident you are on your model, that it will uh, predict better on the generic data, is it actually an intelligent system, or just memorize your sequence or data whatever you have, and then it is able to uh, just generate the prediction on the basis of just memorization? Or is it able to generate or predict on unseen data as well? As so that confidence will be measured by you only. As ML engineer, you have to measure the performance of your own model on the unseen data, and then you will check the accuracy of that data on the unseen data, and then you will say that okay, my model is 90% or 80% is confident. Out of 10, 8 times it gives correct prediction, 2 times it is giving wrong prediction, and that two times you will do some failed cases analysis, you will fix that pattern, you will add that data corresponding to that kind of patterns, and then you will teach again to learn the patterns. So this is how ML cycle goes in the particularly ML model development, sorry. So now you have understood that there is a test set, and there is a train set. Now, let's say in your model development, ML model development, your when you train your model on the training set, also you will check the accuracy of the training set itself. So there it is performing 100%. So it is able to predict the next your output 100% accuracy on the training set. But on the test set, it is giving just 30%. 10 after 3 is correct, 7 are wrong. Then what kind of model you have developed? There is a fixed terminology on this. So basically, what you are trying to fit, you are trying to fit patterns into a model or your algorithm. You are trying to fit. But what happened during this fitting? You have uh, like train the model in a memorization way, or you have crossed the limit of fitting the model, that is a overfitting. So I'm just uh, explaining you or giving you explanation about overfitting. It's not yeah, you should not explain like that, but it's just for memorization, that overfitting means you are trying to fit the pattern into a model, but you have overfitted it. So that's why it's known as overfitting model. Okay. Now this is a terminology. Basically, in many interviews or basics, people ask what is a overfitting and what is underfitting. So this is a overfitting. Underfitting we will later understand. So basically, you understood the test set and training set. So okay, now you have got the idea. So overall, what you will do is, first you will take data and split it into a test set and train set. Then you train set, you give it to the model for the learning. It will catch some patterns. If your algorithm or is complex enough or correct to catch that pattern, then it will able to catch that pattern. Now you have that if you are confident that on the training set it has performed well and it is able to catch the pattern of a train set. Now this test set you will check on the performance. For the performance means how it has performed. So on the basis of this you will take the final decision whether to uh, go ahead with this model or not. Because if you don't have a test set and you train the model on the complete set and you say that on training set it's giving 98% accuracy, and now I am going to deploy this model has never seen an unseen data. And the core philosophy behind a machine learning is to teach a machine on a known data to predict on unknown data. So it is all about generalization of your data, or creating a system where you teach the model first with your own data, and then you ask model to predict on unseen data. This is all about machine learning. So this is mainly the cycle. Now comes here in the train set itself. While creating a model, there is no simple just input and output that you give train set and you give this algorithm and then you come out a new model. So train set itself we need to divide it into two part. Why it is there? It is a validation set and training set itself. So why it is required, we will understand in the next lecture. So as of now, just have a rough idea that complete data can't be fitted into the mod for the training. We have to divide it into two sections, so that the test set, which is a smaller section but has the coverage of the train set, or overall the data, it has some different patterns and different coverage of the data which will be there in the future. You will use that data and check the performance, then you will confidently say that whether your model is good or not. So this is all about this lecture. In the next lecture, we will understand more about why training set needs to be divided into two set again, training set and validation set, and what is validation loss, training loss, and how you finally finalized one model why you need to train the model again and again with a different epochs, why not in one epoch. So all this we will understand in the next lecture, and that's it. Thanks for listening. We'll meet in next lecture.